So here are several examples that use right triangle trigonometry to solve for missing sides or perhaps angles. So please keep in mind these triangles are not drawn to scale. They're just arbitrary triangles with labeling with the given information, and that will change from problem to problem. So here are a couple examples where you're given one of the sides of the right triangle and you have to find the other two. You're given the two acute angles that make up the right triangle, so you're welcome to use either one. But in this first example, we are given the hypotenuse. Okay. So in being given the hypotenuse, again, I'm just going to redraw this so I can label what I have. A is 17 degrees, B is 73 degrees, and my hypotenuse is 7. And I need to find x and I need to find y. So your job for the setup for this will to first of all realize what you have, and then you choose what you would like to use. So you don't just pick sine, cosine, tangent. You want to say, okay, I'd like to first find the x value, and I'm going to use the 17-degree angle, and I'm going to use the 7 hypotenuse that I was given. So in choosing all those things, then that leaves me with the x is adjacent to the 17-degree angle, and 7 is the hypotenuse. So if I choose that, adjacent and hypotenuse ratio is cosine. So my setup will be the cosine of my 17-degree angle is my adjacent side of x over my hypotenuse of 7, and now I'll just solve for x. I'll multiply both sides by 7, keeping it on the left so I don't put it in there with the 17 and have some kind of calculation error. And I get 7 times the cosine of 17 degrees is x. So that's an exact value. And if you'd like to do a decimal approximation, just make sure your calculator is in degree mode. And I get that the x is 6.694 for a side length. Okay, so x is 6.694. Now to find y, it is a true statement that I have two sides of a right triangle, and to find my third side, I could use Pythagorean theorem. My only caution to you about that is the hypotenuse is 7 squared. If you'd like to use the leg of the 6.694 squared, you need to actually use the entire, what your calculator gives you for that leg and not just the 6.694. And then that will add y squared. We square both of those values, subtract them. You end up with 7 squared minus that big decimal squared. Square root the answer. You get 2.0466, but that's a decimal approximation for y. Whereas if you were to use trig, you would get a more exact answer without having to make sure you keep all the decimal places. So if I'd like to use the trig functions to find y, I'm still going to use my 17-degree angle, but now I'm going to go in and use, so I use my y value of my hypotenuse, and in reference to that 17-degree angle, the y value is opposite of my 17-degree angle. So if I use opposite with hypotenuse, that's the sine ratio, and the sine of 17 degrees is opposite y over hypotenuse of 7. So again, same process. I'll multiply both sides by 7. I'll get that 7 times the sine of 17 degrees is my y value, and I'll get that my y value is 2.0466, which is what I got before with Pythagorean theorem, but again, that used the entire decimal that my calculator showed for that side length when I solved for x to begin with. You're welcome to do that, but you have to use every single decimal place that the problem gives you. So my y value is 2.0466. I do believe I've solved for the other two missing sides. All right, next example. We have, again, I'm just going to redraw it. A is 12 degrees, B is 78 degrees, and the y value is 4, so I'm finding x and I'm finding r. It doesn't matter which one you want to solve for first, but what you have to do is just pick something and go with it. So in this case, I think I'm going to use my 78-degree angle, and I think I'm going to pick x to solve for first. I know your online software will have an answer box first, but you can really pick whichever one you want to solve for first. So if that's the case, 4 is adjacent to that 78-degree angle, and x is opposite to the 78-degree angle. And of course, r is just hypotenuse, but we don't really need that for this one. So opposite and adjacent is the tangent ratio. So if I take the tangent of 78 degrees, it's the opposite x over the adjacent of 4. I'll multiply both sides by 4. And x is 4 times the tangent of 78 degrees, which is approximately 18.819. So that's the approximation for x. Okay. So again, we're at the point where we could use Pythagorean theorem to find the missing r value, or we can just use trigonometry ratios. I'm just going to use the trig ratios because I think they're shorter. But you can use either one as long as you keep the entire decimal for x. I'm going to use the 78 degree again, along with the side of 4. So that's adjacent with hypotenuse, so that's the cosine ratio. So cosine of 78 is the adjacent 4 over r. Now r is in the denominator, so it's not as easy to solve for. So algebraically, you would multiply both sides by r and get r times cosine of 78 degrees equals 4, and then divide both sides by the cosine of 78 degrees. So exact answer is 4 divided by the cosine of 78 degrees. Approximation for that would be 19.239, if I rounded it, is the estimation for our hypotenuse. So again, the exact answer has the cosine value in it. You don't use the degree mark in the software for Wiley when you input it, but it's 4 divided by the cosine of 78. Okay, so there's the missing sides for those two. Here's another example, very similar, but all it does is give you one angle. So I'm just going to write directly on this one. The x value is 9, and angle B is 22 degrees. Now, I don't know that you'll need it, but in the event you had to find angle A, again, the angles in a triangle equal 180 degrees. The two acute angles added together equal 90. So whichever way you choose to solve it, the missing angle that's not labeled is 68 degrees. Not that you'll need it, but you should be able to easily find it. So if I want to find r and y, I'll go ahead and I'll use the 22 degree angle because that's what they gave me. And if I reference everything to that, the x is opposite, the y is adjacent, and the r, of course, is the hypotenuse. So I'm just going to choose one to solve for. So I'll first solve for y. So if I do that with what I've been given, y is the adjacent side, and I have the opposite. So that's going to be a tangent ratio. So the tangent of 22 degrees is opposite side of 9 over adjacent side of y. To solve for y, again, we'll multiply the y to get it out of the denominator. Y times tangent of 22 degrees equals 9. And then we'll divide both sides by the tangent of 22 degrees. So we have our y value is exactly 9 over the tangent of 22 degrees. Or if you actually perform that in degree mode again, it's approximately 22.276 for the y value. All right, now to solve for the hypotenuse, r. Again, I'm going to use the 22 degree angle and the 9 opposite side that I was given because it's exact. So if I do that, that's opposite, and the r value that I need is hypotenuse. So the opposite and hypotenuse ratio is sine. So the sine of 22 degrees is opposite 9 over hypotenuse of r. It's the same solving process. Multiply both sides by r. Get r times the sine of 22 equals 9. Divide both sides by the sine of 22 degrees. And you get that r is exactly 9 over the sine of 22, or if you want to get the decimal approximation, is 24.025. So our y value, so r value is 24.025 as a decimal, and then our y value was 22.276. And again, you still have, for what it's worth, geometrically, the larger angle will open up to the larger side for side length, and the hypotenuse will always be your largest side in a right triangle. So you still have that check going on. Okay. Some other examples that show up don't give you all the information exactly. So if you had to find all of the missing sides and angles in the right triangle, you have to go off of that standard labeling where C is the hypotenuse, capital A and capital B are the other two angles, and then the sides that correspond to that will go across from the angle for little a, across from the angle for lowercase b, and then the hypotenuse is lowercase c. So for this first example, the A and the B that you're given are legs. You can find very easily C because it's the hypotenuse, and we can do so by doing the Pythagorean theorem. So if I do A squared plus B squared equals C squared, I get 20 squared plus 28 squared equals C squared. 20 squared plus 28 squared is 1084, and the square root of that is a decimal, so it's the square root of 1000. I mean, it may or may not simplify. 74. Let's see. It does simplify, but I don't know that you'll have to for this application for these. So your missing side is the square root of 1184, which is approximately, if you don't do 184, that would probably help, 34.41. Okay, so that's our missing side C. And then the other things that we have to find are the missing angles. We know that angle C is 90 degrees. That's a given. Okay, but in our triangle, you know, depending on our sides, that is a terrible right triangle. Let me try that again. Okay, here's C. You know, make A or B whatever you like. But little a is 20, little b is 28. Their hypotenuse is around 34.41. Don't use it to find anything. But if I want to find angle A or B, once I find one, I can really easily find the other. So I'm just going to find angle A. And I'm going to use my little a of 20 and the little b of 28, because in reference to angle A, little a is opposite and side B is adjacent. So that allows me to set up a tangent ratio for angle A with 20 over 28. And if I want to find an angle, I'll just use the inverse function of whichever one I've set up. So I'll use tangent inverse, and I'll say that A is the tangent inverse of 20 divided by 28. And in my calculator, I'll hit the second button and then the tangent key, and that will allow me to access the inverse tangent button. You don't raise it to the -1 power. You actually have to use the tangent inverse function in degree mode. Type in 20 over 28 into that function, and you'll get that angle A is approximately 35.54 degrees. And then once you find A, angle A, 35.54, angle B will just complete those three to equal 180. So you can take 180, subtract 90, subtract your 35.54, and you'll get that angle B is 54.46 degrees. Or also A and B equal 90. You could take angle A away from 90 and get the same thing. Okay, so I do believe we found all the missing sides and angle for that triangle. All right, second example here has us with one side length, one of the legs, and then one of the angles. So to find the other angle, you know angle C is 90 degrees. So angle A would just complete the fact that a triangle is 180. So in that case, angle A is going to be 62 degrees. Now, again, if you want to just sort of visualize your triangle, 62 degrees here, 28 degrees here, it's not drawn to scale. And you're given that A is 20. You need to find B and C. So just pick an angle to use. I'm going to go with 28. I'm given the adjacent side of 20, and I'm going to find the opposite side of B, just because that's what I'm going to pick. So if I do opposite and adjacent, that's the tangent ratio. Tangent of 28 degrees definitely did that backwards. Let me go back and redo that. This is 20. This is B. The 20 is actually adjacent, and the B is opposite. Apologies for that. So the tangent of the 28-degree angle at angle B is lowercase b over the adjacent side of 20, opposite over adjacent, right? And then if I want to find side B, I'll multiply both sides by 20. And if 20 times the tangent of 28 degrees, it would be whatever side B is. So if I do 20 times the tangent of 28 degrees, B is approximately 10.634 for a side length. Now again, you're at the point where you're welcome to use Pythagorean theorem to find C, but you need to use that entire 10.63418863 squared. You need to use that entire number. And your calculator has the capability to do that. You just square that answer, you add 20 squared, you end up with a really nice decimal that you don't round yet. And then you square root that answer, and it gives you approximately 22.651. Okay, and it's the hypotenuse, it's the longest piece in the triangle, it needs to be bigger than 20, so we're good with that. But the alternate to finding C would have been a trig ratio. So if you wanted to use the 28-degree angle that we went with before, and the adjacent side, C being your hypotenuse, adjacent and hypotenuse is cosine, so I could set up the cosine of 28 degrees equals adjacent 20 over hypotenuse of C, multiply both sides by C, and then divide both sides by the cosine of 28. And when I do 20 divided by the cosine of 28 degrees, I get exactly the 22.651 that I got with Pythagorean theorem. But again, it's up to you however you'd like to do that. But we have solved for all of the missing sides and angles for that problem. Again, you have to look at what you're given, look at what it's asking for, and then it will be your job to figure out which ratio to set up and solve for.